Document DBMS is another type of non-relational DBMS. These databases store data in JSON-like documents, and the most popular document DBMS is MongoDB. MongoDB represents data in the form of JSON documents. Well, it's not exactly JSON, but it is super close to that. Now, to understand MongoDB better, let's use an example to compare it with relational databases. So suppose we have an employee table containing employee information. And suppose now we also want to store the office address of the employees. Now we can add a column to the table to store office addresses. But address is a composite attribute, which means that it is composed of more than one attribute like city, street, zip, country, etc. And relational databases don't support complex attributes, which means that you can't store multiple atomic attributes in a single column. So what you can do is you can break out the components of the composite attribute into a separate table. This is how we generally store data in a relational database. On the other hand, MongoDB encourages us to store data together at one place in order to avoid joins. And as expected, this makes MongoDB sometimes ridiculously fast. So the same data in MongoDB may look like this. All the attributes in the previous relational database are now the fields in MongoDB. Now, this does make read operations with MongoDB fast, but it comes at a cost. Because a lot of employees will have the same office address, you will be repeating the address for every record, which might take up a lot of space. Not just that, it will also make write operations slower, because for every record, you would need to write the complete address. So, as you can see, storing all the data in one record makes MongoDB more scalable and improves the read performance, but it comes at a cost. Okay? Another difference between a relational database and MongoDB is that in relational databases, if you want to insert the data into the database, you would first need to define the schema of the database, which means that you would need to define the tables, the columns or the attributes, the data types of those attributes, the constraints, and the relations between the tables. And every data entry in the relational DBMS need to conform to the schema. For example, suppose we have this employee table and we store three attributes, namely ID, name, and salary. But now, because of some changes in the requirements, you also want to store employees' contact information from now on. But because contact attribute is not declared in the schema, you won't be allowed to add contact information. So first, you would need to alter the schema and add contact attribute to it. And only after that will you be allowed to add an entry containing contact information. On the other hand, MongoDB and a lot of other non-relational DBMS doesn't require a fixed schema. So let's say we are again in the same situation, but this time with MongoDB. So this is our data, and now we want to add a contact attribute. So what do? We simply start adding contact information from the next entry onwards, and the DBMS will not complain about it. So generally, the non-relational DBMS don't have a fixed schema, which is good while writing into the database because you don't have to worry about the schema, but this relaxed schema can create problems while reading the database. For example, suppose this is our database. And suppose this database is being manipulated by multiple parts of your system. And suppose your database was updated with this new record. Now, if you can notice, this new record has an attribute named ID instead of employee ID. And because the schema is not fixed, the DBMS will allow it. Now, suppose in future, you want the information about this employee with ID 9843. And if you will query the database using the attribute employee ID instead of ID, you won't find this record. So in order to avoid these issues, what they generally do in the big tech companies is that they enforce the schema at the application level, which means you as a user of the DBMS have to write the code to enforce the schema. And all the data has to go through this filter at the application level before reaching the database. So non-relational DBMS having a flexible schema is an advantage and disadvantage at the same time. Okay?